Hello guys, what's up? I am Engineer AK, and it's the third lecture of Metallurgy Chapter 2, Metallic Structure and Crystallization. So let's get started. So today the first topic is atomic diameter, right? So if the atom are visualized as a sphere just touching at equilibrium, then the distance between the two centers of a sphere atom may be taken as approximate diameter. So what does it mean? That we are considering the atom as a sphere, right? You can see here, and if you take the distance from a sphere of one center, or from the center of one atom till another, so this is considered as atomic diameter. Approximately it is the atomic diameter of atom or that sphere, right? Here you can see diameter, or if we take from this point till this point, so this is the radius. Let me show you the radius here. So from here till here, right? So it is considered as radius, right? And now the second topic is crystal structure. What is crystal structure? The specific arrangement of atom, ions, or molecule in a crystal, right? Crystal structure is the arrangement of atom, ions, or in molecule in a crystal, right? That how you arrange atom, ions, or molecules in a crystal. And the atom, ions, or molecule in a crystal oscillate about a fixed position rather than statically fixed. So the atom, ions, or molecules in a crystal structure, they are not static, but they vibrate about their fixed position. Like if they are fixed, so they oscillate about that point, right? They are not totally fixed, totally static, right? Here we can see this is the crystal structure, a 3D model, right? That is the way how crystal look like, right? And there are some terms in crystal structure. In order to understand them, like in order to understand the crystal structure completely, there are some terms you should know. So the first one is crystal. What is crystal? A crystal is a solid material whose atom or molecule are arranged in a regular repeating pattern in a three-dimensional. Like if we see here, so they are in a regular manner, right? Like in equal distance, in same pattern, right? You can see them, they are arranged in a same pattern, in a regular pattern, right? So this is a crystal. Now what is space lattice? It is a three-dimensional network of imaginary lines connecting the atoms. So here we can see these lines that are connecting the atoms. If we see in this model, so these brown lines are connecting these green atoms. So these lines are called space lattice, right? These are the imaginary lines that connect the atom together, right? The next term is lattice or lattice point. It is a geometrical arrangement of atom, ions, or molecules, right? Or a lattice is a collection of points that are arranged in a specific way. Or we can say the point in a lattice are typically arranged in a regular repeating pattern such as grid. So if we see in this diagram, so these are the lattice points, right? We in previous we have discussed that these are the space lattice, right? These imaginary line, and these points where they connect the atom, these are called the space lattice, or sorry, the lattice or lattice points, right? These are the points, so you can easily understand lattice points, right? Now another important term is unit cell. You may also have studied in your high schools, but let repeat it. It is the smallest repeating unit of a crystal in a solid material. It is a three-dimensional structure that is used to represent the arrangement of atom or molecule in a crystal. So a unit cell, it defines the whole crystal, right? Like the structure of the unit cell is same as the structure of the crystal. Like if we see this is a cube, right? This is a unit cell, this is a lattice points, and these are the space lattice, right? But if we see this whole structure, so it exactly look like this unit cell. Like if you study this unit cell, so the structure of this unit cell define the whole crystal, right? Do you get the idea? Like if you what if you see like in the structure of the unit cell will be same as the structure of the crystal, right? So for the study and for the like to study it easily and to study it in a simplified way, we take a unit cell, and then we study it, and it possesses the same feature or the same structure as like the whole crystal, right? Now this unit cell is represented by some parameters. What are these? There are 6 parameters of a unit cells, right? And there are three and these 6 parameter includes 3 edges, A, B and C. If you see this one B, this one C, and this one A, so these are the 3 edges, right? And there are 3 angles between the edges, which are alpha, beta and gamma. If you see between B and C we have alpha, between C and A we have beta, and between A and B we have gamma, right? So to define the whole unit cell, right, we need 6 parameters, 3 edges and 3 angles, right? Alpha, beta and gamma, and A, B, C, or what names you give to the edges, right? Now moving forward, so based on these parameters, these 6 parameters, there are some crystal system, and these are classified based on these parameters, right? Now we will see a crystal system is classification scheme used to categorize crystalline material based on the symmetry and shape of their unit cells. Look, unit cells, the unit cells define the crystal system, but the unit cells are defined by their parameters, right? We define unit cell by parameters, and this unit cell then uh, uh, define the crystal system, right? So there are 7 crystal system, right? Total 7, 1 2 3 4 5 6 7, right? 7 crystal system. And you can see if you see the first cube, so in this these are the lengths, mean these are the edges and these are the angles. So in cube we know that A, B and C will be equal, and alpha, beta and gamma will be 90 degree, right? If you see in this structure, so these all lines are equal and these angles are equals to 90 90 each, right? In trigonal all sides will be equal. The alpha and beta and gamma will be less than 120 degree and will not be equal to 90 degree. Then hexagonal, the A and B will be equals, but the C will not be equal, and same alpha and beta will be equal to 90 degree and gamma will be equal to 120 degree. Then tetragonal, A and B will be equal, but C will not be equal, and alpha, beta and gamma will be 90 degree. Then orthorhombic, all the sides will not be equal, but all the angles will be 90 degree. In monoclinic, all the sides will be not equal, but alpha and beta will be equal to 90 degree, but gamma will be different. And in triaclinic, we do not have the same sides, we do not have the equal angle, all the sides will be different and all the angles will be different, right? Now moving toward you may have seen this term before as well in your school or in your college life, body center cubic, right? If the atoms are represented as a sphere, the center atom touch each corner atom, but these do not touch each other. So in BBC structure we have one atom at the center, and this one atom touch the 8 atoms, right? Like 1 2 3 4 5 6 7 and 1 behind this 8. If we see the 3D model, see, like, so the body center cubic look like that, and this is the 2D model. These are the atoms at the corner and one at the center of the structure. Since each corner atom is shared by 8 adjoining cube, and the atom in the center cannot be shared by any other cube the unit cell of BBC structure contain. Okay, so here we can see this atom is not shared by any other cube, right? Like this cube contain this, like if you see in 2D, so this atom isn't shared by any other cube. However, the atom at the edges are shared by other 8 cubes, right? By other cubes. So if we see like how many total atoms are there in one unit cell of a BCC. So 8 atoms at the corners, we know that, and each atom contribute 1 over 8, right? 1 2 3 4 5 6 7 and 1 behind 8 atoms, and each contribute 1 over 8, right? Like if we combine them, so it will become 1 atom, right? So 8 atom multiply 1 over 8, so 1 atom at, like if we combine their masses at the edges, so it will give 1 atom, and 1 atom, we know 1 atom is there at the center. So the total atom in a unit cell of a BCC structure is 2 atom, right? Like if we see, so this structure contain 2 atoms, right, if we combine their masses. And chromium, tungsten, vanadium, molybdenum and sodium, these they have BCC structure, right? Now face center cubic, you also have heard this name, but let's see. In FCC structure, there are an atom each corner of cube, and in addition to it there is one in the center of each face but none in the center of the cube. So what they say, that at each corner of cube we have same, at each corner we have atoms, right, that are shared by some other cubes as well, but in addition there is no one in the center of the face. But in FCC there is no atom at the center but at the faces. Like if we take this face, so it contains 1 atom here. If we take this face, so it has 1 atom there. If we take this back one, so there is 1 atom. And if we see this, so it look like this, 1 at the face and at the corner, 1 at the face and at the corner, right? There is no atom at the center. Each face atom touch its nearest atom. Since each corner atom is shared by 8, so each corner atom is shared by the 8 cubes, and each face atom is shared by the only 1 adjacent cube. But this at the face, this is half shared by 1 cube, and like 2 cubes share the face atom. If you see this, so half, it is the half of atom, right, and half is shared by another cube. Since each corner atom is shared by 8 adjoining cube, each face atom is shared by only 1 adjacent cube. So the number of atom in, now let's see how many atom in a FCC structure has. So 8 atom at the corner and 1 over 8 contribution, right, they have, so total 1 atom, right, same like BCC. But we see there are 6 faces of the cube, 1 2 3 4 5 6 atoms, and each face, I told you that it is shared by 2 cubes, so 1 over 2 contribution in a unit cell. So 6 multiplied 1 over 2, so 3 atom. Like if I combine this and this, so it will give 1 atom. If I combine this and downward, so it will give 1 atom, and if I add back one and at this side, so it will give 1 atom, so 3 atom. So if I plus them, so total atom in unit cell of FCC is 4 atom. Mean FCC structure are more densely packed, mean there were total 2 atoms, right, and there are total 4 atoms. So obviously this is more densely packed, or we can say more closely packed, right? There are more atoms as compared to BCC. So in FCC there are example aluminum, copper and gold and silver. These are the example of FCC structure. So that's it for today, and in next lecture we are going to discuss very important topic, the packing factor, and mostly the examiner asked a question from that topic as well. So in next video we will discuss that. Thank you.